Okay, we're ready to do section 13.5, page 4. So you are planning a vacation at the beach, and the weather forecast is that there is a 40% chance of rain for each of the next 5 days. Assume that all binomial probability requirements are satisfied. What is the probability that you will have rain every day? So we're being asked to find probability of rain every day. Okay, well, we've been told that this is binomial, so we don't have to check that, but let's make sure we understand why it would be. Well, what can happen? It either rains or it doesn't rain, okay? And how many days are we performing the experiment? Well, 5 different times. And what's the probability of success? Well, we're going to consider rain being success, and the probability of that is 40%. So we should write over here that success equals rain, and the probability of success or equals the probability of rain, which is 0.40. Okay, so when we calculate this probability of rain every day, what would that mean? It would mean the rain has to happen on the first day, the second day, the third day, the fourth day, the fifth day, all 5 days. Okay, so the probability that it rains all 5 days. Okay, hopefully that's going to be unlikely, huh? So that's equal to the binomial probability. Okay, now remember how this goes. Binomial probability. We do n, x, p. So n represents the number of trials. How many trials do we have? 5 different days we're performing the experiment. How many days are we expecting success or rain in this case? Well, 5 days, right? And what's the probability of success or rain? 40%. So 0.40. All right, now where do we go? We use, let's write here, use binomial table. Use binomial table. Okay, so we get out our binomial table. What are we looking for? Well, we want our n to be 5, so we go down here to 5. We want our x to be 5, so we slide all the way down to the bottom here. And then what probability do we want? 0.4. So we go, there it is, 0.4. Okay, so 0.010. 0.010. Okay, so what percent would that be? Well, we move it over 2 decimal places, and that's the same as 1% chance. Well, that's good. So we're going to say the probability that we have rain every day is 1%. Not likely at all. Okay, what is the probability that you will have fewer than 3 days of rain? So probability of fewer than 3 days of rain. Okay, so let's break that down. What does fewer than 3 mean? What are our possibilities? Can it be 3? No, because that's not fewer than 3. Can it be 4? No, that's not fewer than 3. How about 2? 2 would work. 2 is fewer than 3. Let's look at our chart. It kind of helps us. Remember, our n is still equal to 5. So let's look at 5, what the possibilities are. When we have n equals 5, our possibilities are anywhere from 0, 1, 2, 3, 4, 5, which means it rains no days, it rains 1 day, 2 days, 3 days, 4 days, 5 days. Okay, so what's fewer than 3? 0, 1, or 2. So those are our possibilities. So we could say the probability that it rains 0 days or rains 1 day or rains 2 days. Okay, so what does or mean? Or means add, so that's going to be probability of rains 0 days plus the probability that it rains 1 day plus the probability that it rains 2 days. All right, now because it's binomial, we're going to convert each one of these into a binomial probability. So how many times are we performing this experiment? Well, 5 days, so 5. How many days do we have success? 0 here, and the probability of it raining is 0.4. So here again, binomial probability, still talking about 5 total days, but it's going to rain 1 this time, so we put a 1 in there, and then we put our probability in. Remember, this is what I'm following here. Number of trials, number of days, number of successes, probability of success. So how many trials do we have? Still 5 days. How many days of success? 2 rainy days. Probability of success, 0.4. Okay, now we go to our chart and look up all these things. So let's move this up a little bit. Okay, and so what are we looking for? We're looking for 5 for n. So if we go along here, what do we have? N equals 5. Okay, so the first one we need is 0. So 5 and 0, where are we going over to? 0.4. So so notice that, 0.078. Okay, and then we have 5 and we want to do 1, so we slide it down to 1 and all the way over to 0.4. So we have 0.259 and one more now, 2. So down to x equals 2. 0.4 is 0.346. Okay, so we're going to add up all these probabilities. We need our calculator again. So we say, oops, somehow we turned it off there. Okay, 0.078 plus 0.259 plus 0.346. And that gives us 0.683. If we convert it to a percent, we're going to move it over 2 places. We have 68.3%. So in words, which I'm expecting you to do on your homework, the probability that we will have fewer than 3 days of rain, can I fit it all in? Let's just go down here, is 68.3%. Okay, got that there. All right, so that's pretty good. Looks like it's a good chance that we'll have fewer than 3 days of rain. All right, last problem is on Giancarlo Stanton of the Yankees. He has a postseason batting average of 300. So notice that batting average is just a percent, the number of times you hit the ball over the total number of times you're at bat. So really we would say 30% of the time he hits the ball and gets on base. Okay, if we ignore all other factors, so there's all kinds of issues that come into this, but we're going to ignore them. What is the probability that if he comes to bat 4 times, he gets no hits in today's game? All right, now notice it doesn't say assume the binomial probability requirements are satisfied, but we're going to go ahead and think them through real quickly here. Do we have 2 possible outcomes? Yes, he either hits the ball or he doesn't, okay? Or gets on base or doesn't. Number 2, do we have, 2 possible outcomes? Then we have the probability of success remains the same. That's where we have to ignore all the factors. And then the idea that they're independent of each other, that's probably not true. Probably if you didn't hit the ball, maybe you're psychologically messed up and all of that. So we have to use this ignore other factors, okay? So, but there are 2 possible outcomes of success and failure. And so we're going to go ahead and say, ignoring everything else, we're good. Okay, we do have a fixed number of trials. How many times? 4 at bats. So this is our N. Okay, so we're going to say binomial, that it's binomial. Okay, so what are we trying to find? We're trying to find the probability of no hits. Okay, so probability of no hits means 0 hits. And if this is going to be binomial, we have to decide that's n, so 4 is, remember we go n, x, p. So what's n? 4. What's x? 0. No hits. And the probability of success? This is our p. Okay, so we're going to use the table. Binomial table here. Okay, n equals 4. So here we have 4. And then we want an x of 0. So no hits. And p is 0.3. So that gives us 0.240. Okay. And if we convert it into a percent, it's going to give us 24%. So let's answer the question. The probability that he gets no hits out of 4 times at bat is 24%. Okay, so think about that. That's kind of remarkable, isn't it? That's why baseball's so tough. He has a 24% chance of getting no hits in 4 at-bats. So that's why it happens so often. They go for 0 for 4. And his batting average is a really good one. And that's kind of amazing. That's not a really good test score, is it? All right, so at this point, you want to finish up your last classwork problem, and then we are done with section 13.5.